I was joking before that if I was given the topic to talk to, I thought if I was going to do one from scratch, it might be my client wants to buy a new self-propelled, how do I counsel it? And I guess there's a lot of issues in around guys updating machinery, and usually by the time you've gotten to them, they've already made that decision about what they're going to buy, how they're going to go about it, and you deal with the consequences of that after they've started spraying. So I guess in this talk, I'll talk about a couple of issues that typically pop up with self-propelleds, and some of the things to look for when you're doing inspections, and how to talk to your clients about that. So what are we looking for? And the take-home message is that, you know, increased capacity, in other words, more hectares per hour, can actually be a really good thing if it increases efficacy. But typically guys try and do that by increasing speed without adjusting other things, and that can have consequences of its own. And most of the issues I see in and around paddocks are related to speed and guys not managing that well. So I think as advisors, when you're doing an inspection, you need to be able to just identify some of those common things that can happen. So the typical changes that happen when most guys move to self-propels, if they haven't been there before, the first thing they normally do is increase the speed simply because they can. The machines are much more stable. You know, if they've gone from a trailing rig, they might have sat in the mid to low 20s. Get an SP, suddenly they'll be up into the high 20s, sometimes 30s. I was talking about an example up near Canamble, where I'd gone to visit a farm. They wanted to do some stuff, some training for their staff. I spoke to their two Irish backpackers. I said, how fast do you drive the machines? They said, oh yeah, 25, 26. And I've been into the dealer who'd actually clocked that they've been sprays on, doing a job at 52 k's an hour. And you know, at that speed, you physically, the capacity of that machine can't even deliver the volume they're meant to achieve. I don't know whether they just cut the wires to the alarms or what they did, but so speed's generally increased, and that brings about things that some guys mightn't have seen before. Look, booms may be wider, it depends on whether it fits into the farming system. But I think, you know, a wider boom, if they can manage height and maintain it, it's actually a good thing, because that will increase capacity, more hectares per hour without sacrificing things. But with the speed and the width usually comes increased height, and that'll have a few issues of its own. You know, the increased clearance of most self-propels can actually reduce some of the wheel tracking and turbulence issues to a point. So there can be some improvements in certain aspects of spraying. The other thing I'd mention is probably just looking at wheel centres and how well they fit in with other systems. So if they're on controlled traffic, you know, one of the common things we see is guys buying machines that are metrically plumbed, all their wheel tracks and implements are on inches, and it doesn't all fit perfectly. You know, they've got to be all metric or all imperial, I believe. And the last thing is they may be going to bigger tank size depending on the machine, which will have issues with just mixing, agitation and those types of things. So there's some things that you need to be aware of in terms of when they change machines. The first thing I mentioned was obviously height. Now there's obviously going to be a minimum height above the target to maintain that double overlap. And going above it doesn't necessarily affect the overlap. It'll increase the amount you leave in the air, may increase their risk a little bit. The old adage is if you normally, or should be sitting about 50 centimetres above the target if you've got 110 degree nozzles and 50 spacing. If you go above that to about 70, you can increase that airborne fraction up to about fourfold. And a metre above the target at the top of the stubble, you know, you can increase that by tenfold. So some of the coarse nozzles we've got now, sitting down at 50 centimetres, if you could actually maintain it there above the target, might only leave up to about 1%, 2% in the air max. But up at a metre, they might leave up to 10%. So that's one of the issues with them. I'll get back to the other ones, and probably the biggest impact, as I said, was that of speed and what consequences can have in the paddock. The first thing I mentioned is just, you know, you will get increased interception by stubble, particularly with getting into your sort of medium to coarse droplets. Once you start increasing the size a little bit, they'll hold their direction quite a bit. So the faster you travel, typically the more impact that'll have. So if you've got a lot of forward speed and your nozzle's pointing down, your droplet direction is going to be heading in that way. And most of the air induction nozzles we use only have a downward velocity of about 20 k's an hour. So as soon as you travel faster than that, the net movement's going to be mostly forward. And if you're travelling at 30 k's an hour, then you'll increase that horizontal direction. And you'll see that, you know, that's why companies like Syngenta and others are playing around with angled nozzles and twin nozzles to help offset some of those issues. Particularly becomes important as you move into coarser droplets. Bigger droplets and bigger travel speeds end up resulting in stuff like that, where you got, you know, a lot of control on one side of the plant, not much on the other, particularly with compact products. The other thing that can occur with increased speed is the shadowing you get in and behind stubble. We did some work just before Christmas up in the Mallee looking at just how much reduction in deposit we're getting in behind stubble. It was around 30 or 40% of that of what we got in between the rows. And, you know, that started occurring at speeds of 18 to 20 k's and higher. So you don't have to travel very fast to overcome, you know, the downward velocity there to start getting shadowing and things like that on the other side. Once you get to coarse droplets or larger, they're not going to redistribute as much as, say, a medium droplet would have and give you that sort of evenness out in the paddock. So shadowing's an issue, interception on stubble can be an issue. The increases in dust and wheel tracks. Generally speaking, most machines will create problems with dust, but I think your higher clearance machines, those issues are typically less. Most of it will come down to things like tyre size and design and how much air they shift either side. And you know, dust will, in most circumstances, probably start somewhere around 12, 14 k's, and then the faster you go, the worse that problem will become. And the last one, oops, fat thumb. The last one is that, you know, increased speed will have wake effects around machines that will increase losses to the environment. And I think your self-propels perhaps improve that over some of your trailing rigs. In some studies we did, we were looking at drift, not last summer, summer before, we were showing even a trailing rig at about 22 k's an hour was throwing stuff up to 20 metres in the air behind the machine. Not out on the wings, but directly behind it. So from an advisor's point of view, I guess some of the implications of that is when you're having a look at a paddock and you're trying to identify if there's something going on out there, it'd be really nice to actually have some record of how it was sprayed with you. And I think it'd be good to have a copy of the spray record if your clients are doing them well enough. And so the sort of information that would be useful out there is obviously, you know, did they actually put the product you requested on? And if they did, what rate did they put on? Did they substitute that or something else? May happen. Obviously details about the paddock, dates, times, water source, that type of thing. Details on the application itself in terms of volume, speed, nozzle, those type of things. Weather parameters, especially wind direction, can tell you a hell of a lot about whether it's an application issue or not. So if you know what the wind direction was when they were spraying, it may show up in certain ways in the paddock, and I'll try and talk about that in a minute. Another essential thing is to know what direction the sprayer was travelling. Because is that interacting with the sort of thing that you're seeing in the paddock? It'd be nice to have controller settings, maybe have some nozzle charts and other details with you, but you know, that wind direction, wind speed and a few other things are quite important when you look out in the paddock. And I guess when you're looking for application issues, I mean, normally guys don't look to the spray record until they see something they don't like in the paddock or the results less than they expected. But with application, normally the pattern will be repeated in some way. It's not likely that you'll just get it in a single point. It'll be a repeating thing when they do the same thing again. And as an example, if one of those jobs was done with a ground rig and one was done with an SP, which one would you think is which? Can we have a vote? So who would vote for the left one as the SP? Okay, those 6 people are right, the rest of you are wrong. That's what you get for not voting. That one's actually done with a trailing rig, that's done with an SP, and this is actually 2 halves of the same paddock. Slightly different timing when they were done. What do you think the wind direction was for each of those? So in this instance, it's actually a trailing rig travelling too fast into a headwind, we've actually got a crosswind coming across and it's causing an effect on the left wheel there. If I was out in the paddock looking, am I going to see that every wheel track or every second one? Every second one. Oh. That over there, am I going to see that every wheel track? So just looking at when you go out and do an inspection, the first thing I'll be looking for, is it a consistent thing? Is it on every wheel track? And if it is, where's it likely to be coming from? So to be able to assess something like that, you'd have to cross at least 2 sets of wheel tracks, look out on the boom, in close to the wheels in the centre, and probably on both sides. And that's what I put on the next one. The other thing was probably to look at those different parts of the boom and what's happening with them. So is it an issue just out in the centre section of the boom where you've got clear airflow, or is it something happening in and around the chassis? I'd suggest walking across the whole lot and comparing it, and even out on the overlaps of the booms, particularly if you're coming into points or something where guys are using auto section control to look at the looker heads actually doing that correctly. And you won't pick that up unless you sort of walk a couple of sets of wheel tracks and leave different parts of the paddock. It's just water sensitive paper. I was trying to look at a way of just showing visually some of the things going on. So that's with a coarse nozzle at the small end, 60 litres, 22 k's an hour. And we're looking from the left boom, then outside the left wheel, inside the left wheel, centre of the machine. I've got to get skinnier thumbs. Inside the right wheel, outside the right wheel, and on the right. And this is basically the same positions, but behind little clumps of stubble, and that's only, probably 6-inch, 7-inch cut stubble, fairly thin. You probably see that there's definitely, you can see an effect next to that right wheel. That's because we've got the wind coming across the machine, it's actually slightly from behind. And there's a big impact behind the stubble sitting there on that. You can see probably a slightly reduced deposition in the centre line of this machine, but inside the wheel we've actually got higher deposition. You say, well, what's the difference between that and that? If you actually go and measure it, the average deposition down there is about 20 to 30% lower than what it is up above there, even though it doesn't look visually that different. And if I go to, say, a 30 k an hour example, the wind's slightly coming from behind, again from the other side, but that drop off behind the stubble, particularly in and around the machine, is much higher. And so, you start seeing those effects of reduction and shadowing and those types of things from about 16 to 18 k's onwards, and they just increase as you increase speed, particularly with coarse droplets. So, you could say to someone, all right, let's whack some wheel track nozzles on there and see if that fixes it up, our knockdowns to get a bit more deposition there. The trouble is, if I put the same nozzle on this side and this side, I'm going to be overdosing quite a bit there, so I don't want to do it with anything that's going to have a plant back or potentially touch up crop or have residual issues. And so if I was going to put wheel track nozzles on there, I don't think I'd be putting the, just bigger size in on the wheel, because these tyres are actually shifting it out depending on the wind direction at the time. My instinct would be to put say if I was using 025s, I might put an 015 in at half space, but in a bigger droplet size, just to drop a bit more product down there. And so speed effects will also vary depending on the wind direction at the time of application. But quite often, if you've got the wind coming across on one side, you'll see a lot of effect in and around the wheel on that side. And a reduction in deposition on the other. So it can be quite an interesting thing. So what else should we be looking for in the paddock? Probably also looking at the ends of runs or anywhere where guys are going to reduce speed or duty cycle if they're using aim command. The typical standard single nozzle's probably only got about a 5 to 8k speed range at best. So if guys are sitting on 25 k's, by the time they drop back down below 16 or 18, or particularly 18 to 16, somewhere in that range on turns or bags, a single line machine's not going to perform that well. If guys are dealing with that sort of range, it'd be nice to get to them before they bought the SP and say, well, why not looking at a 2 or 3 tier boom system where you're getting the benefits of, you know, 2 nozzles, where you can run the first one, the second one, and both. I think we're a bit slower to catch up a lot of WA guys. But a lot of 2 and 3 tier systems are now available on a single line. We just plumbed up machines that are running 5, 6 tier systems now, if you want to go that far. So there are ways of doing it. But I'd say wherever you see areas at the ends of paddocks where guys have slowed down too much and droplet size got too big, or the minimum hole in the control's too high and they've actually come in and touched it up, got a bit of crop damage because the rate's too high, they may need to adjust their application volume or look at things like bigger headlands and that to manage it. So wherever you see poorer control, you always got to try and rationalise to yourself, how did this happen? Compare it to other bits and be able to talk to the guys about it. The other thing I do is just look at stuff between stubble lines or between rows in the crop and behind stubble lines. Certainly you can see a bit of difference in control there sometimes, particularly with bigger droplets. One of the things that does tend to improve bigger droplets are narrower spacings on the boom to even that up a bit. So we'll also, you know, compare it in relation to wind direction too, because typically when you see that sort of control on one side of the plant, if it's a coarse droplet, that's a function of travel speed. If it was a medium droplet, that's probably wind direction at the time. So it just depends. And if that was a medium droplet, it probably wasn't at a high enough volume. That one was actually a coarse. When I showed that before, that was a coarse to very coarse with a guy travelling at 33 k's an hour. So, yeah, and all they did was manage to hit one side of every bigger weed. Now, most people would tell you if you left it that long to control it, you're probably pushing shit uphill anyway. The other thing I'd suggest, just keeping records of areas of poor control and compare it to other parts of the paddock in relation to soil type, looking at stress and things like that and cropping history. There's the one thing about poor application, if you're used to getting misses, you're going to miss the onset of tolerance or resistance. Good application and trying to keep things clean will help you identify when problems are starting earlier. Listening to Bill's talk earlier, Bill Campbell's talk about resistance development. I mean, you want to see that as soon as you possibly can to control all survivors. If you're seeing issues like some of these, which you think are related to application, and you've got clients that won't perhaps slow down in some situations, run some of those numbers past them about what it's going to control stuff if they do, you know, miss the onset of resistance or those types of issues. So I thought that was a really good talk earlier. So what are the implications for your recommendations? Well, I think most people, I don't know whether they recognise it or not, but most clients I deal with staple your recommendation to their half-written records and call that their spray record. In other words, they're relying on you for correct identification of weeds, crop and pest situation, rates and that, and they'll write down whether and what they did in their record. So what you're writing down is forming part of their legal record keeping system. So it's got to be adequate and accurate and hopefully maintain some sort of legal side of things. Your recs should give enough information to allow the job to be done properly, but it shouldn't be too restrictive for the operator or have legal implications for either of you. By that I mean there's some information that would be really good somewhere in there. Most people are going to be identifying the target species situation, product names, all of those things that we talked about before that make a good record. I'd be talking about things like minimum spray quality they need to use, remind them about that. I've done it again. Minimum and maximum application volumes where they exist, but at least a minimum volume. Don't just give them a single volume to work with. Give them that or above so they can actually make adjustments to speed or volume to suit the paddock. I put general statements reminding them that, you know, some products have things like no spray zones or restraints on the label, and just something on there to remind them to read the label, and they would be printed statements somewhere, and an expiry date for the recommendation. In other words, this is good for the next 5 or 7 days. After that we need to talk about it. In other words, if you haven't started spraying till 10 days time, maybe we need to have a chat. The things I would not put in a recommendation are anything to do with the application, specifically the setup itself. I wouldn't be telling a client what nozzle to use. I wouldn't be telling them what pressure to operate, because if you define one of those things, you've got to define every aspect of it, because you can't say whether they're going to go up on the speed, you're going to give them a speed range, you're going to do all that for every rec. probably doesn't make sense. A spray quality and minimum volume. Those discussions about nozzles and that, probably best done pre-season. One, you can think about what they've already got, how it fits into their program, and maybe what they're going to need based on the products they're likely to use coming up. So, do some sort of spray plan. It doesn't have to be that formal, but you need to think about the products that are going to be applied that season, and some of the ways you get the best out of it, which probably means sitting down with a nozzle chart, talking to them about the volumes they're trying to achieve, what speeds they want to go, and they're probably going to be over here. You probably end up agreeing to be somewhere in the middle, and they're still going to go at the speed they want to do. But just looking at their choices and what that means in terms of droplet size and things like that in the paddock. There are New Farm and some of the other guys have some online tools for help to assist with that sort of nozzle selection stuff. But essentially having a fairly simplified plan saying, look, we may be putting, we may have a lower volume range and a higher volume range, and we might look at some of our fallow products that have to be coursed down here, and if we're double knocking, we might pick a nozzle we can crank up and get in a medium and a higher volume, or we may have something that'll hold its spray quality over range. But typically, guys are going to need at least 2 sets of nozzles, plus their streaming nozzles to cover most situations. And if you can say to them, all right, well, this group of products fitting with this particular nozzle in that range, you can usually come up with 2 or 3 sets that do absolutely everything. That's a printout from my website. There's free nozzle tools on there, but there's other ones that other companies have developed as well. So you can actually input, your speed and your volume requirements, your pump capacity, what sort of spray quality you're chasing, and it'll give you a list of maybe 6 or 7 different nozzles that'll do the job, and it'll pick the one that gives you the biggest speed range first through to others. And it'll talk about settings like pressures and flow rates and speeds at which and where people might consider setting the minimum hold, that type of issue. So that compares a range of different nozzles on the market. As I said, it's a free tool, and I think the details will be in the notes anyway. So I think there's a lot of benefits that can be held from self-propels, particularly when there's times like minimal labour, operator comfort, and those types of things are quite a useful thing. And I think if you're going wider and bigger and it's giving you more hectares per hour without doing a whole heap more on speed, that's probably a good thing. But if guys are achieving hectares per hour with more speed, typically that'll mean more risk as well. And because GRDC pays me to talk about drift as well, I've got to slip something in about drift. Everyone gets fact sheets, but they're getting so many, I'm not sure that they're all reading all of them thoroughly all of the time. And there was a fact sheet about inversions there, and if you look at the new label statements that say do not spray under surface temperature inversion conditions, and you read that fact sheet, which is a plain English version of what's on the APVMA website, it actually says that growers should anticipate an inversion every night between sunset and sunrise, unless they have one or more of the following, which is rain, heavy low cloud, or the wind speed remains above 11 kilometres an hour for the whole evening. If you don't have any of those, it's actually illegal to spray at night according to those definitions. And if you're scaling up capacity, in other words, more hectares per hour, and part of that is with higher booms and higher speed, your risk is going to be higher. If you do that at times, some products may end up where you never expected. A lot of the drift we've seen around the country in the last probably 10 years has been as a result of increased capacity and probably night spraying with the addition of guidance, particularly in summer. So just something to make clients aware of, that if something goes wrong with a machine covering more hectares per hour, it's going to probably be a bigger problem than it was when they were only covering 30 or 40 hectares an hour with a ground rig. And they're now doing 60 to 80, sometimes 100 with an SP. So take-home messages is that increased capacity can improve results, and I see a lot of farms guys doing great jobs with SPs. I don't necessarily have a problem with them. Where I do see issues, it's purely related to the guys at higher speeds, and higher speeds are not trying to manage or adjust for it. And so sometimes issues like dust, there's not a lot you can do about those. At some stage you're just going to have to slow down unless you're getting onto sort of permanent wheel tracks and firming things up. And last thing for you guys is just being able to identify if application has contributed to a poor result in the paddock, and decide what you're going to do about it with a client. How are they, one, going to fix that problem? You know, is it just speed, or are you going to put more volume on it? Are you going to try different things to try and clean it up? But if guys don't get used to getting clean paddocks, they're going to miss issues like resistance development. So I might leave it there for any final questions. Yeah, I think anything you can use to visually show your clients what's going on. We're going to do that at Swan Hill next week, water sensitive paper, it's fluoro dye, run a couple of volumes, a couple of different speeds, and just look at if we're doing a different type of application, would that be enough? Then you've got to come back and do the same thing in crop when they're thinking about fungicides and insecticides. So we'll do this one for summer fallow, then we'll come back and look at it in crop thing. But I think it's good if you can show your clients. Water sensitive paper is a great tool for showing what's going on around the machine, but also deposition in and around crop and down through it. It's a great idea. A lot of growers will carry the water sensitive paper with them just to assess what's going on and compare it to each other's. That was the growers were actually having a bit of competition about who's getting the best deposition now. So I think everyone needs to understand the limitations of each machine. A standard nozzle on a sprayer, an air induction type's got a 5 to 8k speed range. The AIM command with its pulse width modulation, if you run it at a 70% plus duty cycle where it should be, you're only getting about 30 to 40% more speed from that. So you might get 10 to 12 k's. If you expect it to give you a 15 to 20k range in the paddock without under or overdosing, or dropping the duty cycle too low, then it won't do everything. And I think people, you've got to get your expectations right. Most nozzles are, punching out at about 20 k's an hour in a standard one. As soon as you drive faster than that, you're competing with what it can do. Like I've seen people run front booms that actually make dust issues worse. Running in front of the wheels doesn't seem to be much better. In most cases, guys will just put either bigger nozzles in behind the sprayer, in behind the wheel. I'm not necessarily a fan of that because the wheel's just going to shift a lot of that anyway. I do like plumbing in extra probably either side of the wheel, but with a smaller flow rate and bigger nozzle, as I said. But I know guys that run their crop shields, the crop separators, they run those for fallow spray to reduce dust and movement behind it. So aerodynamically, there's probably a lot of things that we could do that we haven't tried yet. I think there's a lot that can be done, but the higher clearance that you get, less suction and turbulence you get at the back, most of it's coming off the tyres. If you didn't have the need for so much traction, a split lug instead of a solid lug will balance the weight of the thing well and displace less air, give you less problems at the back. Most guys with dust, if they can get onto permanent wheel tracks, they'll reduce that into a lot within 2 to 3 seasons. And then you've got to look at generating them. But I think, in terms of looking at the farming system, and there's some things we could do with the machine, getting the booms further back and down out of that airflow, better guards over the top to reduce the air that's sucked in. There's a lot that can be done to minimise it, but you're not going to eliminate it. The only thing that will remove dust and wheel track issues is probably slowing down a fair bit. The rest of it's just trying to manage the problem. The question was, is there an interaction between running air inductions at low pressure and oils? And I'd say, yeah, it depends on your starting droplet size, because the amount of venturi or air inclusion you'll get in droplets will affect their ability to be retained on target. So if you collapse the air, you get a high percentage of stuff bouncing off. And if you're in the middle of course to the smaller end, I don't think it's going to make, so small end of course towards medium, probably doesn't matter if you collapse the air. But if you're at the big end of course or getting into very coarse and you collapse the air, it can have a fair bit of consequence. So where I see issues is someone might have something like a mini drift 025 row 3 on there. It's, you drop below 3 bar, it's very coarse. And they're only operating at 3, 3.5, and they come into an end of a run, they slow down, they're trying to do a grass spray, and they're on the limit of volume to start with, the pressure's dropped down, they've got very big droplets, and they're saying, why didn't I do a good job at the end there? So a lot of that could have been improved by, either coming down half a size and getting the pressure up, or running a higher min hold, but that means overdosing. But yeah, there are issues with some air inductions. The oil-based formulations can collapse the air within the droplets.